Hi, welcome back, my friends. This is William M. Briggs for episode 31 of Uncertainty and the probability for crying out loud, the logic of science. Can't even speak my own name. We're going to do, we started last week, or we ended last week with chapter 5 in James, Queer Uses of Probability, and we looked at how to judge scientific evidence or any evidence that we're presented with, and that we don't have to accept how it is presented to us. We are allowed to bring our own hypotheses in that explain certain data or certain observations or certain claims that people are making. And this is extremely useful in science, especially in judging scientific claims or in claims that come from the so-called media, which we're going to do today. We're going to continue on in James. I think it's section 5.4. I'll have it on the blog and on Substack, and it'll be comments down below. You take a look. Here's the idea. People might start off with disparate opinions about a certain matter of fact, some proposition, and as evidence accumulates, they may view this certain proposition. They may be they're somewhat believing about it, or they may be somewhat skeptical about it, or people may have a whole range of beliefs about the certain propositions. But as evidence accumulates, the idea is, the claim is that people, even if they start this far apart, one guy is a strong believer and another guy's a strong skeptic, as evidence increases about a particular claim, they should come closer and closer together whatever the proposition is, true or false or in between or something like this. But beliefs should come closer together. This is, after all, the impetus behind the idea of increasing education and raising awareness, our most favorite slogan in our democracy. If the people believe that if your awareness is raised on a particular topic, why then you have to believe a certain way about it. And is that true? So here's the claim in a mathematical sense. Let's just suppose, and now I picked something that's controversial on purpose. This is the claim. We'll think we're back maybe in 2016 or something like this. The claim is that Trump, or 2020, both, that Trump is a Russian asset. President or president-elect or the candidate Trump, however you want to think of it, is a Russian agent. That's the claim. Now, we're thinking about this before we've had all this information that we have at our present date. We're putting ourselves back a few years in time, let's say 2020 or 2016. This is the claim. This is a very controversial claim. Now, before you would have had any evidence from the news media or anything like this, you might have had a thought about this. You might think about, how does this guy get to be so popular? So we're going to start off with somebody who is, this is the particular proposition of interest, is this Trump is a Russian agent. And here's just person A. And this person says, well, I think there's only a 10% chance that it might be true based on whatever background information that they have. Now, the exact numbers and figures aren't important right here, okay? So we're not married to this 10% probability here. It could be 90%, and some people who are exceptionally, those people who really distrust or dislike Trump, those people might start higher, and people who are more in the middle may start even lower than this. It doesn't really make any difference. It really doesn't make any difference, because we're going to contrast this with a person B who thinks about this and it more or less dismisses it, thinks, well, there's always a possibility, right? It's a contingent event. Anything contingent, we went over this last week, anything that's contingent should have a non-zero probability for most things. You can allow that it could happen. It could be a very small probability, or you could dismiss it entirely. But if you dismiss it entirely, there's nothing wrong with dismissing it entirely, I should say. But then you can't budge from that position. New evidence, unless it's contradictory of the prior evidence that you hold, won't change your beliefs on that particular proposition. We covered all that last week. So go back and review all that if that's confusing. But we'll just use these figures because they're different. They don't have to, the particular figures I use don't mean anything per se, except that the direction of difference is important. So this person's more or less, well, we won't call him a believer, but he's not absolutely dismissive of this idea, whereas person B is. The difference in these probabilities is about, well, it's exactly 0.09. Okay, so now the claim is by all these economists and others, and Hausen and Urbach and their book Subjective, or is it Bayesian probability or subjective probability, influential philosophers of probability. The claim is that as new information comes in, D, we'll just call it D data. I'm more or less following James's notation. I changed it up a little bit. He does a larger example. I'm doing a smaller one because it's all the same. Just makes it easier on this smaller board. The claim is that as new information arises, the claim is that the difference between the probabilities after the people update, that difference will be smaller than the difference that they initially started with. That's the claim. And so we'll go through some numbers here, and we'll plug some numbers in, and we'll see if this is a true claim. The claim is, in fact, not true. Not true. It can be true. It's not true generally. It is absolutely not true that as new information comes in, people move closer together. They can. Sometimes they do. Sometimes, if new information comes in and the data is utterly irrelevant, like today is Tuesday or whatever, obviously that data is irrelevant to this. It's not probative of S. And so the new data comes in, and however people started, they would stay exactly the same. So new data can come in and people don't move at all. People can come in, they can come and have data that would cause them to move closer together one way or the other. That's absolutely true. But it is also true that people can get data information in that causes them to move further apart. And isn't that exactly what we see? This is James's point in this entire chapter. I think he's the first to look at this, and I'm surprised economists haven't picked this up. Especially in light of some of these things, which I think we'll cover, the so-called conjunction fallacy from Kahneman, Tversky, and who did they pick up eventually? Kahneman, Tversky, and he wrote a book, How We Know It Ain't So. Gilovich, Tom Gilovich. Anyway, so we'll look at those claims, and we'll see how damning they really are or are not when we analyze them in terms of a deeper probability understanding, a logical probability understanding. So we'll come to all that. So let me just make a little bit of a side note here. This right here, this probability is the probability the proposition is true given the evidence dA. Now we can, and we will use here in a minute, we'll use Bayes' formula to help us compute that, to help us compute it, to aid in computing that. But it doesn't necessarily mean we have to use it. This is just the probability of S given all of the evidence D and A. That's it. If sometimes Bayes is helpful, sometimes it isn't. I think that I've mentioned this several times. I've never actually done a demonstration of it numerically. But I have an illustration I did years ago on the blog. Maybe I'll do a class on that just to show you. We did deduce that Bayes' theorem is the form of probability should take. If it takes any kind of math at all, it should take Bayes' theorem. And we deduced that the numbers are between 0 and 1 and all these kinds of a thing. We did all that a long time ago. And I'm not saying anything negative about Bayes' theorem, except that it's not Bayesian probability. Bayesian probability ends up being too subjective in ways we've talked about before. However, this is just all the probability, all the evidence that we have, and we're calculating, or sometimes we can't calculate, but we're judging the logical truth of this proposition with respect to this evidence and with respect to this evidence. And we're seeing how far apart those are, if we can calculate them. Okay. So now let's introduce these two people. We do have this person who's somewhat willing to believe, although not a true believer, and we have a skeptic in this position. So now, just because here's Bayes' theorem, we're after this probability. I put a little dot here to represent A or B. We want the probability of the proposition of interest given the new evidence, D, which we'll talk about in a second. I haven't told us what it is. And a dot, meaning A or B. So we just plug this into Bayes' theorem here. That's the probability of the so-called prior belief multiplied by the probability of that particular data, assuming S is true, assuming Trump is a Russian agent. Same thing, first part in the denominator, and the second part is the probability, the initial probability we don't believe this, times the probability we see this data, assuming this is false. Okay, that's just standard Bayes theorem. I didn't want to keep writing it down every time, so I just wrote it like this. Okay. So now I want to make sure I don't want to have to do math in front of you. I made up all these numbers. Okay. So we're supposing now, we are supposing that it's true. Trump is a Russian agent. We're believing this, okay? Yeah, this is the thing about probability that is a sticking point for a lot of people. It's not whether this is true or not, it's whether or not it's on this side of the equation. If it is true, these are statements of logic. We can make all kinds of statements of logic with counterfactuals and all this kind of stuff. We did all that a long time ago too. But if we believe that Trump is really a Russian, we need our D here. But we're going to believe, yeah, we're still going to solve this. We're going to calculate the probability of this D, whatever this new data is, assuming Trump is in fact a Russian agent. And then we're going to calculate it again, assuming he is not a Russian agent. And that because we need these probabilities in Bayes' theorem to make it work out. Now, here's the thing. Here's the new evidence. News reports on what do they call themselves? This was a big thing. The New York Post broke it. How many security chiefs or security assets or security individuals and national security agents, all these people, security officials in the United States government, one way or another time reports that Trump is a Russian agent from experts. Anyway, you remember there were lots of reports of this, that all sorts of sordid details in these things. But the news reported this, and it was backed up by these claims of all these experts, John Brennan and all these other people. I forgot the exact phrase they used. I'm terrible with these kinds of names. It's in there, but I can't bring it to mind right at the point. But you remember that this happened. So it's important to understand that this is the news reports that these security experts claimed the Russian dossier, all this kind of stuff, Steele dossier, whatever it was true, and Trump was a Russian agent. This is the claim. They reported this. This was not proof in the sense that they had other things that they might have had, secret recordings of Trump and Putin in some Kremlin dungeon, just dividing up the world. Greenland goes to Trump, and China goes to Putin, and all this kind of stuff. Nothing like that. This was the reports. Now, this is the news. The so-called news reports this. So that's the evidence that we have. That's the evidence that anybody had at the time. I mean, not everybody. I mean, the people involved in all this kind of stuff, they had different information. We're not calculating their probabilities. We're calculating the probabilities for the people, just average people who start with these kinds of beliefs, and then they hear this. Now, assuming Trump is in fact a Russian agent, he is. What's the probability that the news would report that these experts claimed he was? Well, I think for both people, the probability would be 1. This is James' example. He uses a different thing. He didn't use Trump. Of course, he didn't know about Trump. Died before Trump became a well-known political figure. But I think he used ESP again, but I didn't want to keep sticking with ESP because I wanted to mix up the examples a little bit and use something that was much more controversial. But even the guy who's willing to believe it, he says, yeah, the news would definitely report this if Trump was a secret agent or a secret asset. And the guy who's even a skeptic, they said, yeah, if Trump really was a secret agent, certainly the news would report this. They both agree on this. Okay, so there is agreement here. Now, let's talk about this person. Now we're assuming Trump is not a Russian agent. He is not a Russian agent. Absolutely not a Russian agent. That's what this equation means. This person is asking, what's the probability that the news would report he is a Russian agent? And I think the number I picked was 0.01. What does that mean? That means this person doesn't believe the news would report that Trump is a Russian agent if in fact he is not one. In other words, they trust the news. This is the standard. This is people who watch television, that kind of a thing. They believe what they see. They listen to NPR and they accept it as gospel, kind of a thing. But they do allow, mistakes happen. reports come in, they get garbled or mixed up in some ways, or all kind of different things might happen. They allow that there's a possibility that it might happen, but it's not very likely. They only give it a 1% chance. The exact numbers here aren't really important to us, but you get the idea. They allow that there's a possibility the news might report he's a Russian agent by mistake or something like this, even if he isn't. Now, our skeptic over here takes an entirely different view. He takes more like I would call a realist view. And he says, if Trump is not a Russian agent, would they report him as one? And he says, oh yes, very likely they would. News media, the propagandists have been known to lie and exaggerate, especially for people that they dislike vehemently or are paid to at least pretend to dislike vehemently, to read whatever they have to read on camera. So this person here is much more cynical or realistic, however you want to put that, about what the news media would do and what these expert security personages would do. So he is much more cynical. He said, yeah, even if Trump's not a Russian asset, they would very likely report that he was. So now we want to calculate this probability here. What's the probability for both of them that they believe this now? Okay, so we have to plug the numbers in here. I'll just do it up here. So this probability, they started at 0.1, and the probability of the data given, assuming Trump is an agent, is 1. That's repeated. This is for A. I'm going to run out of board space, of course. Plus the probability that he's not a Russian agent, well, that's going to be 0.9. Their previous belief before they heard this kind of news, they thought he was probably not, but they allowed he might be. And now over here, they said there was only a 0.01 chance. And if you plug all those in, we get to 0.92. Okay? That's A. That's for person A. We just plug this stuff into the formula. This is, again, just in case you're not following it, this is their prior belief, the belief they came in without hearing this news. They allowed that there's some kind of a chance, not big, but some kind of a chance. They said if Trump was a Russian asset, the news certainly would report it that way. And we repeat this first, the numerator and the denominator, so we just have that here. And this is their prior belief that Trump is not a Russian agent before hearing the news. And then the probability that the news would report that he was, given Trump is not, is for them 0.9. And we plug all this in here and we get 0.92. Now we do this for B. B is going to be 0.01. That's his prior belief. We did that. And his probability of the data, assuming Trump is a Russian agent, 1. And we repeat that. And we have their belief that he's not is 0.99. Whoops. 0.99 times here, 0.9. This is their belief that if Trump is not a secret agent, the probability the media would report it. And if we plug all those in, we get roughly, these are all approximations, roughly 0.1, this for B. Now, the difference is in the face of D, I should put a little D over here. The difference in the face of D is 0.92 minus 0.1, which is 0.82. And we started with 0.09, a difference, and we now have something that's almost 10 times as high, and probabilities have diverged in the face of new evidence. This person did believe a little higher. This person went from 0.01, person B, to 0.1. They did increase their belief a little bit that Trump would be, might be a Russian agent. This is just like to use the slang online, a boomer con. You know, a person who reads National Review or something like this. They're not entirely dismissive of the idea in the beginning, but they allow that the news is piqued their curiosity a little bit. They were somewhat skeptical of the news at this 0.9, but they moved to 0.1. I should circle the 0.1 to make it a little bit easier to read. So they increased from 0.01 to 0.1. They went up 10 times, relatively speaking. This person over here, though, they went up from 0.1 to 0.9, and they went up 9 times. So they went up less in a relative term. That's why using relative moves and probability, we're going to come to all this when we look at modeling and so forth. Is not the way to go. Using relative, it has its uses. It can be valuable. But a lot of times you can just, if you saw a headline, you know, the people, boomercons are 10 times more likely to believe Trump is a Russian asset than even blue people. They only went up 9 times, you know, so that 10 is more than 9. Therefore, Trump really must be a Russian asset. They would use arguments like this. And if you think that's asinine, it is, but that's the kind of stuff we see in medical papers a lot. You know, the new thing is cured or caused by some factor in the environment or behavior or something like this. These are the kind of reports we see all the time. We're using relative changes in probabilities. Don't do that. We got absolute probabilities. Why? We can calculate them easy. It's no extra work. In fact, we have to calculate these absolute probabilities before we can calculate relative changes. So let's just stop at these most of the time. That's the useful thing. But in the end, however, they were not that far apart in the beginning. But upon hearing the same news, they're now a lot further apart. A lot further apart. 8 or 9 times farther apart. So that's a huge difference. And so now the next bit of news they hear, this person is at a different spot. The next bit of news that they come to, this, you know, it could be negative or positive in favor of Trump. It'll cause them. It's not that you know, it depends on the news source. This is one source. If they heard it on a source that they hated, they're more likely to believe that source lies, and so forth. The point being that as the same information comes to people, because the way they treat that information differently, they can come to completely different views about the proposition that everybody should be, according to standard Bayesian theory, should be coming together to agree upon. But it just doesn't happen that way. It just doesn't happen that way. Disagreements are caused, and they can be analyzed in a very neat way like this. Now, your homework is going to be, you have to go and find, you can always, it's the same one we did last week, more research shows. Look up research shows, you know. That's all you got to do is look up research shows. And you'll always find new news daily on new research shows, kind of a thing. And there's nothing stopping you from forming these after the fact. What did I think about this before I looked at this new news? And you can see whether or not how your beliefs change in this kind of a fashion. And you could work through this example even though you might not have access to anybody who is the opposite from you, but you could certainly look that information up on social media or something like this, and you could see how people are reacting to this news and how they're moving, how they either believe the source, and they would never make a mistake or never lie or never shade or never cut or anything like this, or whether they are somewhat more skeptical and jaded about how the world works. And so you can see how these acrimonies develop. And it's the same thing in voting. I have another video you can look up on the site. It's not part of the class, but it's about voting. The same kind of thing happens in voting. I'll just real briefly cover that. In voting, in a democracy, drives people apart. It drives people further and further apart and makes the groups that are at war with each other more distinct and more different than each other, and for the very easy reason. Suppose you have a group that's coherent of people, and they want to have a certain goal or direction, or have a set of goals or directions or something like this, and they want to elect a leader, and they differ on the leader who they think will best realize those goals. They all vote, and some people will be disappointed that the guy they wanted to be the leader didn't win, but everybody will still be somewhat satisfied because they all believe that the goals are going to be worked towards. All right, the values that they hold will be upheld. Maybe not in the most optimal manner because they would have rather had A than B or something like this, but everybody is more or less happy and then we can continue. But when you have groups that have completely different views and they're voting not for the goals, I mean, not for the people, but the difference in the goals, which is what we have in our democracy, the people who won are very happy because now they get to make sure their enemies don't try to do to them what they just did to their enemies. And the people that lost will be even more bitter because their goals are no longer going to be worked towards. And so they become more obstinate and more definitive in their views. And so do the people that won. It drives people apart. Just the general voting, and the more things that you vote on, the more chaos and acrimony you're going to cause. That's why in democracies where everything is based on these kind of emotional responses and everything, just get worse and worse and worse, and why democracies eventually end. Okay, that's it for now. You're going to read James chapter 5.4, I think it's 5.4, but I'll have it down in the notes. And you read that section. It's got more in-depth. His example is bigger, and lots. He discusses the kind of political nature of this thing too. So it's just there's a lot of insight in James you can gain. So read James. Try to do the research shows homework from last week and this week. Marry it together, and you'll find it's actually quite easy to do. All right, I'm not certain what we're going to do next week. We may continue on in James chapter 5, probably not. May move to his chapter 6, and we eventually have to get to cause. And I think that's chapter 7, and uncertainty. That's going to be a big, complex topic. I'm apologizing right now. It's going to be very difficult to get through cause. More errors are caused by incorrect notions of cause than anything else. And in fact, that's the whole reason why I'm doing this class. So we're going to have to spend a lot of time with that. And I'm always hesitant to get into it because it's going to be rough. All right, that's it for now. You can look below, go to my site, wmbriggs.com, or the mirror at wmbriggs.substack.com.